So I'm going to go to my home screen on Replit, and I want to create a new Replit. And my Replit is going to be C#. So I'll pick my C# language. And then this is going to be lesson 04. And let's call this first method, because it's just our first method that we've written. Perfect. So when I start out, Replit has already given me my main method method header here. Thank you so much, Carol. So we've already been given that as an example, but our main method is actually kind of a hard method header to remember. So that's why that one Replit in the early on ones asked you to kind of memorize that so that you could type it quickly without having to go look things up. I did not do that when I started coding C#. It took me quite a while to get to where I could type out a main method without having to look at an example. And I kind of handicapped myself by doing that. So I'm going to start out up here with my using system. And I know I want to add that using static system.console so I don't have to keep typing my console keyword. And then I want to block comment. So I'll do my // make my comment, program. This one is our first method. Put yourself as the developer. When we're using the Replit, it's really easy to not do any commenting. So force yourself to do commenting, even though in Replit you're just kind of banging out the code. But when we're doing a special one, especially make sure that you're putting in some commenting. Our purpose here is going to be explore methods. So the first thing I want to do after I've got my comment, I'm going to go ahead and label my closing curly braces. Here's the end of my class, and the one right above that is the end of my main method. Now today especially, we'll see why we want to label those closing curly braces, because any methods that we create need to come within between those two closing curly braces. So our new methods must be within our class, but they must not be within an existing method. So notice how we have to make sure that we have our open and closed curly brace for our existing method. And now we're going to put in our new one. Let's put a comment up here. New method called my method. In this method, I'm going to start out with public and static. And we're just going to kind of always put those two modifiers at the beginning of our method names while we're working in our main class. So when we're working with a C# class, like our program class here, that has a main method, we have to use this static keyword. We will find ways to avoid that in the future, but for now, we always have to have static. And we just usually put public when we're beginning because we haven't learned much else. So that's just keywords. Now, this method is going to return nothing. So I put void. And it's going to take as input a variable. We're going to call that input variable my variable within this method. And I want to keep my closing parenthesis there with it. Now, there are two styles of the open and closing curly brace. You can see Replit does what I would consider the Java style, where the opening curly brace is on the same line of code. This is more the C# style here, where we have our opening and closing curly braces on their own line of code. Either one is fine. It works fine either way. Just don't let it confuse you that it can be different like that. Now, this method is not going to do very much. All it's going to do is write out a line to the console. And what it's going to write out is the variable is, and then the value of the variable. And we've seen much fancier ways to do that with different write lines and lots of formatting styles. But I also want you to know that the simple way that you learned in the Intro to Programming classes works too, that I can just concatenate variables to strings. Now, in my method, I'm going to add some comments here for defining it. First of all, public, this is called access mode. We're always going to leave that as public for right now. Static is required for our main class. And it means that we only have one. It's like it's embedded in our code. Now, the next keyword, void. This is our return type. If our method returned any data to its caller, we would have to say what data type that was here. We use the void keyword to indicate there is no return data. Try some examples of both today so that you can see the difference. They call that a void method. It does not return any information to the caller. The next thing we have is our method name. After the method name, we have our opening and closed parentheses. Parentheses contain the parameter list. Now, the parameter list could have more than one variable in it. This parameter list says double variable. And this actually creates a variable named my variable that is a double. So I can use that variable name within my method body. See how we use that variable name, my variable, within our method. It was a variable that did not exist before, but since it came in our parentheses of our parameter list, C# is going to create it. Now, these comments that we're putting in, of course, are our learning comments, right? They're not the kind of comments that we would put in if we were creating this code at work. There would be a little bit of overkill on comments, and the advanced programmers would be, what's your problem? That's pretty basic stuff. But while we're learning, they're important comments because they help us identify all these different pieces of this method header, because like I said, they can be a little bit overwhelming at first. Okay, so now I've created this great method. It's sitting over here. It's like this little black box that's ready to do things. It's like, just call me. Let's have some fun, and I'll do some things for you. So let's call it. Here in our main method, let's change our one line of code to call our new method. All we have to do to call it is type its name. So my method, that says C#, go see if you can find this method somewhere, and if you can, run it. But my method expects some data. It wants some input, so I need to pass that to it in my parentheses. So if I had a highlighter here that I could use in Replit, I would highlight this, right? Because I would want you to notice this 7.5, when we call my method, the 7.5 value is going to be copied into this my variable. So its data is going to be available within the method. Let's try it and see how that works. Let's run it. Get the slow boat here. Thinking. Finally, I get my output. The variable is 7.5. That looks right. Is everybody's work okay? Any errors? Anybody got errors? Can you share them with us so we can help you fix them? Let me stop here so you guys can share. Okay, one of you share that has an error so we can help fix. Did you figure it out? Anybody else got any left? So we can show us what you got. Yeah, do the share content button here on your Teams meeting and show us what you've got. So if I look over here at the messages, I see a whole bunch of errors. Let's go up to the very first one. And if you notice, it's on line 11. So line 11, it says, oh, something's missing. That line where we say my method 7.5, we need that to replace this old console.write line. Okay. So let's move it. The main method is just the beginning of your program.
I had a question about that too. So it's essential to remember that instead of having like normally I see all these IEDs like just write it out for us. I don't know if it's something important we should probably know. Or,
your main method.
Yeah.
Yeah.
It's good to
yeah, it's good to just be able to. Perfect. So no, good questions. You guys just keep asking. That's great. So whenever our program starts running, the system is looking for that main method to begin running. It finds that, starts up, and then does whatever our main method says. So let's try in our main method, let's add another line of code here after we call my method. And let's call my method again. This time, we'll set up a variable, double, and I'll just call this variable A, and let it set it equal to 12.5. Now this time when I call my method, I'm going to use that variable A. So as I run this, let's look at what should happen. Execution is going to begin at our main. The first thing it's going to see is this call to my method, passing a 7.5. Our my method is going to start running. C#. Thought I was. Am I not?
You're at the other screen.
Oh, okay. Thanks. Is that better? Is that the right one? Okay. Okay. So our main method starts running. We see this call to my method passing an argument value of 7.5. The 7.5 is copied into this new variable, my variable, and we begin execution at the beginning of my method. My method outputs this message, and that's it. Then it's done. So now control is returned back to the main. Our main continues on, declaring a variable A with a value of 12.5. Now it calls our method again, passing in that variable A. The value 12.5 is copied into our my variable, and our my method is run again. So we're going to see our my method run twice. Let's run this and make sure we're accurate. Our output should be the variable is 7.5, the variable is 12.5. We should see both of those messages.
In between the main method and end of class, that's where we put all our functions that we make.
Yes, for right now. Exactly perfect. And we want those functions to be before our final closing curly brace for our end of class, but not interrupting our main curly braces. If that makes sense. Try to keep them all where they were. So here again, I got my method to run twice. The first time I got my 7.5 output, and the second time I got my 12.5 output. So let's take our break, and when we come back, we'll update our program to add a method that returns a value so that we can see how some of that works. And then we'll break for time for you guys to work on your replets. I hope you're working with your groups. I know some of our groups are working super effectively together. I hope if your group hasn't kind of made that transition into being effective, that you keep trying, because I've had so many people after our class is over say that working with their group was like one of the best things, that they didn't realize how much it was going to help them, but it helped them a lot. So do give yourself that benefit. Come back at 9:20 and we'll finish this up. Okay, ready? We're back. Let's go ahead and continue on. We are looking at our method here. But what if we do want to return a value? We're going to make some sort of method that's going to do a great calculation, and we want to return an integer. Look at this method header. Notice how it's just a little bit different. Important points here. Our modifier still says public static, but now instead of the word void here for our return type, we have the data type int to say the variable I return is going to be an integer. Then we have our method name still and our parameter list. Notice when we're looking at our parameter list again, we're specifying data type, variable name. So here our method is specifying return data type, then our method name. So we get used to that in C# that we've always got that type first, followed by the identifier or name. So let's make this new method in our code. We're going to say to return something, we use the return keyword. So this example here of our my method that returns an integer, we return just a value of 0, and that's all this method does. That's a valid method if we want it to be. Whenever we return a value, we use the return keyword, and then we specify a variable name or some sort of value or whatever to return. In C#, we can only return one thing. In Python, you can return like multiple items from a function, but in C# it can only be one thing, so we have to be careful about that. Here's an example of our my method that's been updated, or we have a new my method to return an integer. In this call to our my method, we've said that our return type is int, and within our actual code, we've issued this return statement. Now, a return statement does a math problem, and we cast the answer as an integer. This math problem says, take the my variable and multiply it by 2, and then make it into an integer. and that's the value that's going to be returned. So let's update our my method to work that way.
What's the double there for in the variable?
The double is for the parameter type that's going to be passed to us as input, that it is a double data type. So super good question. Now let's fix this in our my method. Our original my method just said, I'm void, I return nothing. We can change that now, and let's make it say int. That means I return a value is integer. I'm going to update our comment up here because our comment said void, return type, void indicates there is no return data. I'm going to add another comment there, kind of indent a little bit. Int says return data will be an integer. So we changed our void to int to say we are going to return some data. If that's the only change I make, I'm going to get an error if I try to run my program right now. The compiler is going to say, you said you had a return data type of integer, but you don't have a return statement in your method. I'm going to let it run so we can see that error so you know what it looks like. It says not all code paths return a value. So again, it's not a super friendly error message, but it's saying that in your method header on line 25, you said you were going to return an integer, and in your method, you don't actually do that. So let's add that code. How do we want to do it here? We're just going to return a value, whatever my variable times 2 is. But I said that I was going to return an integer. So if I try to run this like this right now, I'm taking a double, my variable, and I'm multiplying it by 2. So the result is going to be a double. We're going to get an error again. This time it's going to complain about the fact that we said we want to return this data, but the data we want to return is in the format of a double data type. And we say our return type is an integer. So again, we're giving C# mixed signals, and it's saying, I can't convert this double to an int. Well, I can force that to happen by doing a cast. When I do a cast, I specify a data type within parentheses, and that says cast this answer is an integer. Now, whenever I cast like that, if I was going to come up with invalid data, my program would cancel, because that's an implicit conversion. I'm telling C#, really, it's fine. Convert it from a double to an integer. I could have a problem there. But in our case, I don't. But I would like to do something with that. Let's run this first. Now that we've got everything conforming, we shouldn't have any errors. We should see our original output, the same as we were getting before, our 7.5 and our 12.5. So our method has run, and whenever we return data, we didn't catch that data anywhere. We didn't have a variable set up to get that return value. So that return value was just dropped, as they say, into the bit bucket. It just went away. It just was dust in the wind and didn't matter. Now, what if I want to keep that data? Well, I need to have a variable to hold it. So I'll declare an integer value in my main I'm working on line 14 where I call my method. Instead of just calling my method, I'm going to say I want to declare an integer named C, and I want it to hold the return value from my method. The return value in variable C. Now, when I get back to my main, I could print out the value of C. The return value is E. Remember, if I want it to be an interpolated string like this, I have to put the $sign at the beginning of my string. So now, when I run my code, I'm going to call my method once with 7.5, and I'm going to ignore the return value. The return value is just going to disappear. Then I'm going to declare my double variable A, and I'm going to call my method passing that variable A. When my method runs, it's going to do this calculation and return an integer. I'm going to save that integer in my C variable. Then I'm going to output my C variable. So let's run that. Now we should have 3 lines of output. The third line being our return value, which should be our 12.5 multiplied by 2. So when did it cast? If we look at this, notice that it cast my variable as an integer before it did the multiplication, right? Because otherwise I would have ended up with 25 as my answer. So could I force it to do that? Can I change that to make it cast the answer instead of just my variable? Let's try adding parentheses there to see if we can alter the outcome. Because I'm casting, by changing those parentheses, now I've said, after you multiply my variable times 2, cast the answer as an integer. When I didn't have the parentheses here, I was saying cast my variable as an integer, then multiply it by 2. So notice how that order of operator precedence affected our answer. Now, some people, when they're coding, will say, add parentheses, remove parentheses, I don't know, put in plus plus, all these kinds of things just to randomly try. I want you to be very controlled in your updates and know why you're doing things so that you're not just approaching it that way, like, I need a bigger knife, I need a bigger gun, because I can't get it to work. Because if you know why things are happening, that gives you the ultimate control. Yes, sir.
When it converts it to a integer, does it make it then a solid 12 before it multiplies it? Is that why it's?
Yes.
Is that why it becomes?
So it just truncates off that decimal place, just cuts it off.
Oh, just cuts it off.
Just cuts it off and says, you said to cast as an integer, you're going to lose your decimal place. So we could have possible data loss there, right? If we weren't being careful. Okay, so as we look at calling methods, we do have a lot of control. Now, the last part when we're calling methods are these parameters, this parameter list. So far, we've had a parameter, our double value of my variable, but we could add another one. Here I added a comma and then another data type integer and another variable name, my int. I could have a whole list of parameters like that for my method. Now, when I do that, each parameter has its name, and each parameter declares its type, and my parameters are in order and separated by commas. In this example, when I called my method, I would have to pass two inputs to it. So I could use like 7.5 comma 1. Those two inputs then are going to be copied into these new variables in order. The first one goes into the first variable. The second one goes into the second variable. Now, all this information all together, the return type, the method name, the parameters, all of those things are used to build what's called the method signature for C#. So I could create this new my method in my code, and it wouldn't bother my old one. Let's try it. So here's my code. Down here where we have our my method declared, let's add a comment to our closing curly brace, end of my method. And let's create another version of my method, public static int my method. But my parameter list is going to be different. This my method is going to expect one input that's a double and one input that's an integer. Each of those variables, if you notice, is given a data type and a name for use within our method. Now I could make this method be a little different. Let's say I want to declare an integer named temp. Then I'm going to use temp to hold the value of my variable times 3. I'm going to need that to make that an integer because I said my temp variable is an integer. And then finally, I'm going to do a write line. And in my write line, use the interpolated strings with the $sign and say my variable equals my variable my int equals my int, and finally temp equals temp. Let's see if I've got that all right. I need to close my double quote. My parenthesis closes, and I have my semicolon. Okay, so my write line statement for this new my method, I'm going to print out my variable equals, and then my variable's value, my integer and my integer's value, and my temp variable and its value. And finally, I'm going to return that value of temp. Now think about how we could copy all of these comments down before this new my method, and they would all apply. The only thing that's different is the parameters in our parentheses, but they are different. I'm going to put end of my method. This is called an overloaded method. An overloaded method is one in C# where I can have the same name. My method has the same name. But because my parameter list is different, C# will allow it. And C# will say, sure, I'm smart. I'll figure out which version of my method you want to run. And it's going to figure that out based on our method header. So if I change line 14 up here in my main, where I call my method, let's change it. And instead of only passing in A, let's pass in another number, the number 4. We're not actually doing anything with that number in our method except outputting it, but we can see what happens there. So the first time we call our my method, we're going to use this version of it, our original, because the first time we call, we only have one parameter. This version only requires one parameter. The second time we call it, we've got 2 parameters. So C# is going to say, oh, I see. You want to run this version of your my method because it matches the values that you're using to call.
So what's the integer temp? You did like the right at the very beginning of that second function. Why is there integer temp there?
Just because it's easier for us to work with that variable instead of repeating that formula every place we wanted it. Since I want to be able to output that value and return that value, decided it was easier to save it in a variable. Does that make sense? Because that's a really good question. Everybody sees what he's talking about there. Okay, let's run it. So if we were able to trace what was happening here using a debugger tool like that, like we'll try to next time, we would be able to see that first our my method, our original one, gets called, prints out, the variable is 7.5. Then the next time we call our my method, we're using the newer version of it that requires 2 inputs, and its output is this line here. And finally, when we return back to our main, we write that final return value of 37 again, since it was calculated and we used it to return. Overloading methods is something that has to do with object-oriented programming. So it can cause a little blip in our brain as we first start thinking about it. But it's a really, really powerful tool. Here's an example. In this example, I have a my method that returns an integer that expects 2 parameters. And I have a my method that returns an integer that only has 1 parameter. And then I have a my method that returns a string data type and requires 2 parameters. C# will be able to tell which one we're calling based on the data that we pass, what we do with it. So we can overload our methods using the same method name to make it work multiple ways. Where does that matter? Well, think about it. What if you were coding a student search program and you wanted to let your users type in student IDs? That's one way we could search for a student if they put the whole ID in. But you also want them to just be able to like type the last name and search by name. Well, I could have 2 search methods, one that expected that integer, student ID, and I would access my database using that student ID. My other method that expected the name then would access the database in such a way to use that name as a search variable to find the student. So overloaded methods are really, really powerful and really important because they let us call something the same name no matter how we're doing it within the method, if that makes sense. So it's an advanced concept for sure. Now, whenever we're working with C#, we're implementing functions and subroutines all as methods. It's a method, a method, a method. We always call it a method. A method has a unique signature that we develop from its header. We've seen that has to do with the return type, the name of the method, and the parameters that's being passed to it. That method header, the formal method header, specifies those pieces of information so that we can build that signature, a unique identifier for this version of the method. Our methods also have bodies of code, and our method code body is enclosed by braces. Now, as we work through the replit that has to do with methods, you're going to build some specific methods, like one to prompt a user for input, one to do the calculation, one to output information to a user. So you'll be using that hierarchy chart model of, our main method calls our input, process, and output method. For the assignment, as we look at working with methods, we find it here.